Hello everyone. So we will start with our talk. My name is Nav Singh. I'm from Montreal, Canada, working as a software engineer at Manulife. So in this talk, we will go through the history of Android's back button, how it evolves, and what's the current situation, and like which current APIs are recommended by the team to use for handling the back navigation in your Android applications. So for the first four versions, we have like on key down method that we need to override if we want to handle the back, if we want to intercept the back press. And if you see it's on the next slide. So with Android Eclair, they come up with the solution for providing the on back press method for us. And if you see the link for the blog, there was it was the main requirement, main request from the developers to how to handle the back system, like the back system button in our Android applications. So instead of doing that in using the key down method, the team comes up with the solution which is like easy to handle the back press in our Android applications. So in Android Eclair, they introduced on back pressed. And then in Android Q, it was like quite a long time. There is no changes. We are all good with on back press. And then they introduced the gesture-based navigation in our Android applications. So if you want to just recap how it works or what is it, you can just check that YouTube video. So I actually don't plan to having this slide in my talk, but recently I was in situation like after 5 years of using iOS device, I switched to the Samsung S21 Ultra, and the default navigation for that one is like 3-button navigation if you see on the right side, the second screenshot. And I was using all the time that one, and I was wondering like why my device don't have like a back gestures and all that things. And then in Android 13, I found that there is a back navigation, like we see like a cool animation when we switch applications, like when we go back to the home screen. So then I found that there is a settings that we can change. So if you are still using 3-button navigation in your Android applications, you go to the system settings, and then there is an option for the navigation mode, and you can switch between those 3 options, like if you want 2-button navigation or gesture navigation or the 3-button navigation. But somehow for Samsung devices, it was default to the 3-button navigation. And fun part started with Android 13. So if you are right now targeting 13, you will see everywhere, because if you're intercepting back press in your Android applications, it's deprecated. Either you can add annotation on it, like just keep it there, you don't have time, or if you are not intercepting it, you are good. But when you actually hover over the on back press, like that lint warning, you will actually see that it recommends to use the on back press dispatcher, which is like the recommended for moving forward with the handling the custom back navigate, like the back press in our Android applications. So if you want to actually just to recap how it works and why we need it, in the last Google I/O there was a really cool session about it, and it's also called ahead of time model. So what it does is basically the concept is like when user actually performing the back in your application, they know actually where they're going to after performing the back gesture. So until Android 13, the back gesture is basically when your user is moving back from your activities, like performing back gestures in your application, and you are supporting the Android predictive back gestures, they will see the animation when it's going back to the home screen, so that your user knows that they are actually leaving your application. So they can, if they want, they can quit, or if they want, they can just stay there. So until Android 13, it was like only that animation, which is like just when going back to the home screen. So after actually I go through that animation. So I want to see like how it internally works, like what internally changes in the API side. So we know that we can use on backpress dispatcher, but before like it's at the activity level, we get the on backpress method, right? We need to override that one. But when we are using the on backpress dispatcher, it basically this is the code from the view root implementation class from the Android side. So I have added the link in there. You can actually find this code in there. So this is the first stage when the event comes in. So if you see the if block, it says if it's the back event, and the third condition is it's checking like if the back invoked callback is enabled. So if it is, then you see it will automatically get then it calls the get on back invoke dispatcher and getting the top callback. So it will handle the back right away in this class at this point, and it will not go back to all the way to the activity class anymore if you are supporting the predictive back gesture in your applications. So right now, this is the code from the component activity, and this is the on backpress methods definition from that activity. And if you see there, it basically calling the dispatchers on backpressed. And this is the definition, like how it declares in the activity class for the on backpress dispatcher. So it takes the default fallback callback within when it's initialized, if you see there, and it actually calling the superclass on backpressed, which is like the activities on backpress. So it's not calling its own. And if there is no callbacks, you are not providing any callbacks, then the default one is just calling the activities callback on backpressed. And this is the definition of the on backpress method of the on backpress dispatcher. So what it does, it goes through all the callbacks, and it will check if there is any enabled callback exists. It will take that one and execute that one when the backpress event occurs in our applications. So it's basically last in, first out. So when we add the callbacks to the on backpress dispatcher, it was like a stack, and it needs like the next callback will be taken out is like if it's enabled or not. That's the condition if you see in there in the while statement. And if there is no callback found, it will check the fallback. If it's not null, it will execute that one, which is like if you see remember in the previous slides, that was added when the backpress dispatcher was initialized. So now we will see how we're going to add the on backpress callbacks from different components. For example, the first one is activity. So we have a getter on the activity class. So basically this is Kotlin. So on backpress dispatcher, then we get that, and then there is a method we can add callback. It takes 2 parameters. That there is a different versions of it. Like you can skip the lifecycle owner, but this is really recommended so that it will automatically enable or disable the callback when the activity or the given component is resumed, like it's start or paused. So it takes the lifecycle owner and then the on backpress callback. Until Android 13, we have only single method, which is handled on backpress. So you move all the code if you have like on backpressed method already, which is deprecated. You move that code into that in that method, and in the given scope, we also have access to the callback itself. So if you want to disable or enable that callback, we can do that. Like we perform certain actions and then we do this thing. We can enable or we can also remove the callbacks. We will see in the later slides. And the last if block is basically when we are using the on backpress dispatcher, which is Android X library. So it internally handles us for like adding the callbacks for the platform API for versions higher 33 or higher. So whenever we add the callback, if you see the code for that activity class, you will find this code in there that it will automatically update the platform callbacks for Android T or higher versions. And also I forgot to mention the on backpress callback, it takes a parameter which is enabled. So by default it's true. So if you want your callbacks to be initialized as like a default to be false, you can also do that. So that was like how we can add into the activities. Then there is if you are having like a dialogues in your application and you want to handle back navigation in there, you can also do that. So we can access the on-back press dispatcher from them. For example, here I'm using the material dialog. So I created the dialog and then I added the callback in there. So you can do your custom stuff if you want, and then just make sure you disable the callbacks or just remove it when you are done, so that next your back navigation work as expected when it goes back to the activity or the another components, like when this dialog goes away from your from the current context. And the next one is the fragments. And from fragments, it's the same thing, like we need to define the callbacks, and then we need to access the activity, which is the host for that fragment, and we will add that callback. And here it's really important for having the lifecycle owner defined, because the view lifecycle owner is the recommended when we are using fragments because of the lifecycle. So you just define that. So whenever your view is not more in resumed state, it will automatically disable that given callback, and it will be automatically again enabled when it's in the right state. So that was like the old way of doing things when we are having activities and XML kind of things. So right now we are using compose. So we have a back handler. So we can use back handler in an composable if you want to handle the back navigation in your compose functions. So it will take the lambda, and the local on back press dispatcher owner is responsible for adding that lambda to the callback stack for the on back press for the given host component activity for the given composable. So when we do this, it will automatically add the callbacks to the activities callback stack for the back press. So when you create a callback, there are a couple of methods that we can use. For example, if you want to remove the callback at certain point, you can use the method called remove. And then if you want to update the enable state of your callback, for example, let's say we have certain kind of forms when it's edited by the user, and we want to show some sort of like dialogue that when they press the back to make sure that they don't lose their information kind of thing. So you can use like a flags in your like a observable kind of like maybe flows or live data kind of thing. So in there you just observe and update your callbacks state, maybe like set it to true or false based on your requirements. And then the last one is like checking if for the given activity or the given backpress dispatcher, if there is any enabled callbacks exists or not. So that was like the basic overview of the on backpress dispatcher. Now we will see how we can actually migrate. There are a couple of paths, and it basically depends on how you are currently using your, like what's your target SDK, and if you are intercepting backpressed currently in your application. So the first option here is like, if you are not intercepting back at all, you are already good to go. You just need to add the enable on back invoked callback tag to the application tag, and you just set it to true, and it will work for you, and your application is like ready to go for the predictive back gesture animations, and it works out of the box. And this is again the internal function. Like when we add that flag, the activity class, it has a flag called ahead of time back. It will check if it's enabled based on that flag, and if it is, it will just to register the system on back, like the default callback, which is like activities on back press. You see the line, the first line in the if block, it basically calls a navigation back for the fallback if there is no callback found for the on back press dispatcher. So the option 2 is like custom back code. So if you are intercepting backpress currently in your applications and you are using Android X, then in that case we can use on backpress dispatcher, because you are already using Android X, so it's good to go. And it has a couple of benefits when you are using on backpress dispatcher instead of using the platform APIs. So the first one is it's backward compatible all the way back to 21. So This is the first one, and then the single source of truth. So you don't need to do like a, usually we do checks like if the build SDK version is 12 or 10 or whatever, and do this thing, and then if it's 12, do this, things like that. So you just use the on backpress callback and handle like add the callbacks in there, and it works for all the different versions for you. Like it internally handles the Android, like adding the callbacks to the platform level API for you for the versions for 33 or higher. And the option 3, when you have custom backcode and you are not using Android X in your applications, in that case, we have on back invoked dispatcher, which is platform API added in Android 13. And again, this is the limitation, or I can say the opposite side of when we cannot use the on back press dispatcher. So you need to manage the back functionality at multiple places. You need to have on back press method for your older versions, and then for the API 13, you need to actually do like a check. If you're at least running T, then initialize your callback, and then register your callback. And when you are using the platform level API, it has like a, you need to provide a priority. So it basically, there are 3 default overlay that is exposed to the external world basically for the developers. So we can use the default is basically for the activities or other components, and the overlays for like, for example, menus or when you have drawers in your application. So that overlays can take, it has a higher priority than the default ones for the backpress. And then there is a third one, which is the system one. If you see if you remember the last previous slides where I discussed, it checks the ahead of time callback. If it's flag, if it's enabled, then it registers with the system default fallback for callback with the system default priority. And the last step is basically you need to make sure if you want to unregister your callback, this is the best way of doing the things, like you are observing some sort of flag in your activity or wherever you want to unregister your callback based on the value. So that was up until Android 13, and then in beta 2, Android 14, we got a really cool updates for predictive back gesture. So the first one is really helpful, is like we can enable gesture at activity level instead of application level. This is kind of a showstopper for us because our activity, like our application has a lot of activities, and there is other team or squad which is working on one module, and they don't want to actually providing support for the back gesture, or they are not ready yet. So we are kind of blocked by them. And then when this thing get announced, I immediately shared with my team that we are now ready to go actually support into our side. So you can set the flag to false at the application level, but you can enable it for like per activity, say. So you can just add the same flag on the activity level, set it to false or true wherever you want to support the predictive back gesture. And in Android 13, we only have like a predictive back gesture for back to home, but in Android 14, we got a custom cross activity custom transitions support. So if you have custom animations for your cross activity transitions, and if you remember, we are using override pending transitions, that will not work with predictive back gesture. So these are the new APIs exposed by the activity level version 1.8.0. So we need to use this if you want to customize the transitions and make sure they are work with predictive back gesture. So it takes 3 parameters, the transition type and the enter animation and the exit animation. The next thing we got is like the back progress. These are the new methods that are exposed again in the 1.8.0 alpha. So we actually have access to the information when users start performing the back gesture in our applications. So it's via the back event. We get the swipe edge if it's left or right, and then we also get the progress, which is the value between 0 to 1. And if you want to translate or scale any components in your application, you can do that on using the information that we get from the back event. For example, in here I have a compose holder, which is compose view. I am translating based on the progress value, and I will show you the demo later in the slides. And the last one is Android X transitions. Also get in the version 1.5.0, we get a support for predictive back gestures. So if you are using transitions in your application and you want to transit certain components, you can do that. We have transition seek controller. Only the here condition is like we can only use the transitions that are supporting the seeking. So you can check, for example, fade, slide, change bound, they are supporting the seeking. So we can use those with the predictive back gesture. And we can update the views or the whatever animation you want to do with the transitions using the new API, which is exposed via Android X. And it's only for via Android X, so it's not like a platform-based library APIs. It only works for Android 14 or higher. Another update, material design support. So right now it's not in Compose yet. So if your application is using bottom sheets or side sheets or search bar, search view, I misspelled the name, I guess, search view, yeah. So these are the three components that are supporting the predictive back gestures. You just need to update the version to 1.10.0 alpha 3 or higher. And if you see in the demo side, you will see that when I try to perform the back gesture, it actually shows me that where I am landing back my user. This is just demo for the bottom sheet and the side sheet. Search view, you can just check the documentation. So I found there is a new back design, like the predictive back design guide also published on the Android developers channel. And I recently found an issue in the WhatsApp. So I took a photo like this morning and I try to crop that. If you see that when I try to crop that, it interferes with the back gesture, which is like not good experience for the users. So if you are having these kind of functionalities in your application, you need to make sure that your gestures are working accordingly so that it doesn't interfere with the back gestures. And if I do I try to do same thing with the Samsung's Photos app or the Gallery app, they handle it pretty well. We are not having like a gestures. They are not interfering with the gestures when I'm doing the crop on images, but WhatsApp somehow having this issue. So you need to follow. I think this is pretty good design guidelines that we can follow. So this is the demo for the 13. We don't have any cross-activity transitions. So it's just the back to home. It goes back. And in 14, we get if you see that hello world, the world is getting faded when I try to perform back. That is like the transition, Android X transitions. And this is basically the cross activity. So I'm performing the custom transition. If you see, you see the droid cone, it's also changing. So this is actually the cross activities. You can see like where your user is going back. And all the code that I have discussed here, and possibly I have tried to document everything in this sample repository that you can check. I will update it with the new stuff if there is something. I think yesterday we got a beta 3 for 14. I think there is a new updates on the predictive back. We'll see if there is something. And here are a couple of the references that you can check and see if you can provide a support for predictive back gesture in your applications. And it's really helpful, I guess. It's a better user experience, and it requires it's not a lot of work. If you are using Android X, you can just use on back, press callback, and I think you're good to go. And thank you.